Hello everyone, welcome to my YouTube channel. In this video, we are going to see the simulation of positive edge triggered T flip-flop with synchronous active high reset on the software LTSpice. So let us get started. Click over here. I have already made the schematic of the T flip-flop, so I'll open it. So this is the schematic of the positive edge triggered T flip-flop with synchronous active high reset. It required 23 transistors to construct this flip-flop. All the transistors is of 180 nanometer technology node and the width of the transistors is adjusted accordingly. There are 4 inputs over here. One supply input over here, clock input, T input and reset input, and the output is Q. So now let us run this simulation. Let us zoom this part. As you can see that at every positive edge of the clock, output is toggling when input T is 1 and reset is inactive. So whenever input T is 1, means logic 1, output is toggling at every rising edge of the clock. And let us zoom this part. And whenever the input T is 0, output remains in the state in which it was. Over here it is logic 1. And over here it is logic 0. Okay, this is all when reset is inactive. Now let us zoom this part. Now you can see that reset has become active over here. But the output doesn't go to 0 immediately. It waits for the next positive edge of the clock. That means reset is synchronous. And you can see that input T is 0 and reset is active. So output is still changing to 0. That means reset has the higher priority. So we have seen the working of a positive edge triggered T flip-flop with synchronous active high reset. So this was all for this video. I hope you liked this video. If you like this video, give us a like and get subscribed to our channel. And don't forget to click on the bell icon so you don't miss any future video. See you all in the next video. Bye.